Hey, hello all.
Hello.
Hey,
Hey,
good morning.
Niels. Hey, Max. Looks like we are all early birds here, huh?
2 minutes early is early bird. Okay.
Should we wait a minute or two, or we can start? People are still joining, so let's wait a minute. Okay, so we can start with the 5G updates from Daljit. Daljit, can you hear us?
Hi, good morning all.
Yeah.
I'll just share my screen. So we'll talk about 5G SA project status. These are the features we are working on, and there were some features that most of the development is done, but there were issues related to merging the PERs we have. And one of the PERs got merged recently with the network initiator session modification and 5G QoS. And we still have a GTP extension support feature. A PR is blocked, and that's tied up to a package we can discuss in a few minutes. Other than this, the team is working on ongoing testing for 5GSA, hardening the feature, and working on all the testing in the CA. This is the from the defect fixing and hardening perspective, all the issues coming from regression testing and all the issues which are getting merged are highlighted here. So a series of Gen Hub tasks got closed. First one is related to session modification procedures. There were multiple issues got resolved. And then we have AMF is processing registration request is tied up with the mismatching of MNCs. That's fixed. And some logging related changes related to Python script for session modification triggering through CLI. Next one is AMF is not serving registration requests. So it's after even sync up with Redis DB, there was an issue, it got resolved. And then we have three different PERs got merged. The first one is the big one. We were blocked for a while. The search hash and modification changes. This issue is merged. And there's some couple of other issues. One is null check, and then one is related to PDF session accept message. So those are resolved. This is the status of the features we have in the list in the development / testing, mostly testing and merge pending. And the first one, again, we just talked, the PR 12734, it got merged. With IPv6, we have one issue pending to be merged. And this is an internal find, and this is the router advertisement. 5G router advertisement. This is actually, there's some feedback, review comments came in, and we have raised another PR to separate a non-net issue, and that's in progress there. GPS extensions, GTP extensions port, as we discussed, there's one issue which is block and it's tied up with the OVS package. Magma OVS package is heavily tied up with the documentation and versioning related details. And there's another PR raised for that, and we are hoping this can be merged, and we can unblock this PR to be merged ASAP so that we can move forward. This is the 1.8 feature. We have a regular meeting and a lot of discussions going on. From a 5G SA perspective, the CA testing is going well. And one blocking PR we discuss, which is again, tied up with we discussed with the OVS package. Documentation side, we are moving okay, and the PRs are getting merged. And this is the link to the detailed 1.8 status. And I think there are a lot of details here. There are a couple of issues with the documentation related to CA, and there's ARM64 related changes which are kind of need to be looked into, other than the PR the Wavelab has pending. This is very much we have for today. Any questions? All right, thank you.
Okay, so next topic is DevOps updates. So to pick it up, so the Access Gateway AWS AMI image that we were trying to build was finished. Now we are just getting it security checked, and we are also building the ARM AMI workflow. That is also mostly done. We are just doing last minute bug fixing, and we are also writing all the CI process that we have in a document, Google Docs. So I can share the link, and we are continuously updating all these things here, and new task will be added here, and we'll soon move all this content to Confluence so everyone can access it easily. Yeah, that's it. Any questions? Okay, thank you. So we can move on to the next topic. That is, so release updates. We don't have Diljit on the call. Sorry, Diljit is there. I'm Mr. Govind. So, Diljit, do you have any updates regarding the release?
Actually, we can look into, right, the way I was saying. So there are few. It's a lot of discussion we are having in the release 1.8 meeting, and there's the blockers of the PR which is from Wavelabs, right? That need to be merged. And that's base because of this OBS pack, Magma OBS package need to be put in the repository in JFrog. That is one of the issue which is one of the major blocker. And then there's a architecture 64 for ARM, so they are working on it. I think those are the main areas for 1.8. Then we need to create a 1.8 branch and follow with all the release notes and everything, right? So if we unblock on these couple of issues, then we can move forward with creating the branch. And Magma from a Wavelab side, we need, after the PR merge, we need few days of testing. That's a requirement for creating the branch. So we are hoping we can close by early next week, if we can close these issues, and then we maybe Monday we can merge all the PRs from Wavelabs. Then next week can be good to create the branch. But again, we need to unblock on these open items.
Okay. So, any questions regarding the release? Okay. If not, then yeah, we can move on to the next topic, that is orchestrator bug fixing from Sebastian.
Hi everyone, a quick update from my side. Let me just share my screen. So this is about a bug I talked about before a few weeks ago in this meeting. It's a bug that's obvious in NMS, is when you have UEs connected, and after they detach, they will remain as an active session in NMS. And yeah, after quite a bit of work on this bug, we think we were able to fix it. So there's now a new table in Orchestrator that has information just related to this particular session D state. And whenever the gateways connect for the next time, so for the periodic check-in that usually happens once a minute, they completely rewrite this table and they should clean up all users that are no longer connected. So I just wanted to report that this is fixed. There's a fifth step here that's not implemented yet, but that's just cleanup of the old state. It should not, still cause this bug. And there are a few related bug reports about state that's not cleaned up on the NMS side. And so far, we're not sure how many of them are really caused by this or how many might be caused by other states. But yeah, this one should be fixed at least. And that's it from my side. Any questions? All right, then I think the next speaker is Niels.
Yeah, hi everybody. Let me share my screen. So, actually, Amma asked for an overview of Bazel. I think this is a great idea because the last time was a couple of months ago when Marie did a presentation like this in the engineering meeting. So this is a good opportunity to remind you what we are currently working on and show you what is the current state. So Bazel at Magma is an ongoing effort. Sorry. What I want to talk about is give you a little bit of context, what this effort is about, talk about the current make process in Magma and what are subjective pain points, what is Bazel, give a little bit show and tell, argument why, in my opinion, Bazel is helping Magma, and list a couple of to-dos in the current state. So about the context is a migration of the make build system of Magma to another one named Bazel. The main motivation here is to improve the developer experience and the overall build process. Initialized was this effort by Marie and Scott from Meta. They are no longer on the project. Currently, it is mainly continued by Christian, Lars, Jan, and me from TNG. But of course, at some point, it should be continued during regular development. So basically, currently, we're doing the initial setup, and using Bazel at some point belongs to the regular development. So how is Magma built currently? Build, test, and packaging of the Go, C, C++, and Python services is happening with Make, and a couple of called bash scripts for that. Development is happening, development in CI runs usually on virtual machines and on Docker containers. And the deployment of Magma is happening by Debian packages and a new approach to have the AGW gateway set up as containers. So in order to have a comparison between Make and Bazel, a quick simplified structure. So we have a project root, we have a couple of services in different languages. We maybe have some protofiles so the services can communicate. We have a couple of configs, for example, for different environments, dev and production, and we have a make file. And this make file defines building, testing, and packaging. And in some points relies on pre-installed dependencies and the used interpreters. Again, it's simplified. So a couple of pain points with Make. These are pain points from my experience. So some people who are working with Magma might not agree. Feel free after the talk to note that. So, but this is what I experienced when I started with Magma. The one thing with Make, in my opinion, is a problem with the maintainability. Make was used for a long time, so it's grown over time, and some technical debt was created. I mean, this happens for long-running projects. There are some inconsistencies and missing standards. For the usability, on CI, basically everything needs to be built from scratch. Locally as well, but to be honest, of course, there are some approaches to cache the builds. You will see this in a table later, that, for example, building MME with Make uses some caching in some places. The granularity is one pain point I noticed. So there are some workarounds existing, for example, for executing a single test, but this was not easy to find, and I think it was built recently. Some questions for onboarding I found hard to answer with looking at the Make scripts. For example, what targets and services exist actually in Magma, what tests are there, how can they be executed, and what is the actual dependency structures between the services and inside of the services. Reproducibility. There are currently different requirements needed for the environments we are using for virtual machines and the Docker containers. So you need to set it up correctly first, and the term works on my machine. Yeah, everybody knows it. We see it from time to time in the Slack. So it's sometimes hard to reproduce failures. So then about Bazel. Actually, what is Bazel? Bazel is the open source software version of Google's Blaze. It's a build system that uses Starlark, a Python dialect, for build definitions. And it is mainly designed for monorepos with multiple languages. So the idea is that calling Bazel with building, testing, coverage, also builds and tests everything. So you can use Bazel test ... and you actually can execute the Python test, the C tests, and so on. So everything is covered by one technology. Another design point is that it's built for large projects with large builds and a lot of tests. Here the point is that Bazel supports massive caching. So you only have to rebuild something if you actually changed something. And very impressive from my perspective is that Bazel also supports remote caches. So even if you do a fresh up in CI, setup in CI, you don't need to build everything from scratch. You can actually download from remote caches already built artifacts. Also, Bazel has an impressive query language. You can use it to analyze and visualize the structure, the dependency structure of the project. I will give some examples for that. And it is designed for reproducibility. So Bazel aims to create hermetic builds. I wrote here hermetic-ish. I come in a second to that. So the idea is that every dependency will be packaged. So you don't have to pre-install some requirements. You don't need to prepare your system. The idea is to have as much as possible an artifact that you can install and immediately use. Hermetic-ish, of course, it cannot be completely hermetic. So for example, interpreters or the architecture are some points you don't want to have in your artifact. But actually, there are even approaches, if you set it up, if you want to do it, that you can even package your interpreters into your artifacts. For example, the Python interpreter. To have a little bit of definitions, what I will talk about in the next slides, Bazel works with targets. A target is actually a bundle of source files with some semantic information. So do these source files define a binary, a library, or a test, for example? But there's many more. And important also, Bazel always needs a target with a well-defined output. The targets are defined at source level. So this is a little bit different to make, where you can have one big make file. I mean, we don't have it completely in our in Magma. There are different make files, so it's separated a little bit. But Bazel is there way stricter. So every definition should be at source level. These targets then can have dependencies. Other Bazel targets, and important here is that cycles are not allowed. So actually, the build graph has no cycles. Each target is cacheable. So if we have this a cyclic build graph, then we only need to rebuild something if something in the subtree or subgraph is changed. So for comparison now, the simplified Bazel structure. So again, we have our project root with a couple of services. Bazel has the build definitions in build Bazel files. They are defined at source level. So here would be defined how the Go service is built. And maybe a dependency, it has some proto files. Same for the Python service. In the configs, we then maybe have the definitions for the packaging of the project. And then we have two additional files. .bazel.rc contains the global build configuration that is used in the project. And the most important is the workspace file, most important in the sense that this defines a Bazel project, and it contains the loaded external Bazel rules. So if you use Bazel, you don't have every rule for every kind of target, let it be a C test or a C binary present. You need to load it by loading these rules. You can imagine them as plugins, and there are a lot of them for different use cases that are defined in the workspace file. So a little bit show and tell. So Bazel has an extensive documentation and a very responsive community in Slack. Documentation, I will not go through it completely, but this is the entry point, and it's very, you can basically find everything here about Bazel. So how is Bazel executed? Usually you call Bazel, then a verb, can be test, run, build, coverage, and then the target. So for example, Bazel test ... would execute each test in the project. I will not do that now because this will take a little bit of time. So with this one, Bazel test and then a target, LTE gateway Python Magma mobility D ... would execute all tests in mobility D. So if I execute this here in the Magma virtual machine, let's wait a little bit. Then it is very fast. And you see here, because I executed it before, that a couple of tests were executed, each test passed, but it was actually cached. I did it before, so it was now really fast. But of course, in some situations, I don't want to have the cached test results. I actually want to execute them. So what I can do is I add the flag cache test results. No. Execute it again. Then actually organizing the build files, every Python file that is needed for the test. This is still cached. These are artifacts. but the execution of the tests will now happen again. You can see it here. It takes a bit longer because the tests actually run. But for CI, it is of course a good situation if you don't need to run the tests again, because Bazel, by the dependency structure, knows exactly if there was a change that happened and actually if a test needs to be executed again. Of course, we can also execute a single test. So I will not do this now, but it's the same prefix of the target. But then I say with a colon, I want to only execute one specific test. Yeah? But we do not only have tests, we also have services. And this target here defines the mobility D service. And with Bazel build, I can build it. So I built a Python binary. I will do some quotation marks. It's Python. This is not really a binary that is created, but what Bazel does is that it actually fetches all source files needed, all external dependency, and puts them in the folder structure that it can be executed hermetically. So building a service, you don't see much about it, but what you can then do is you can run the service. So, but running a Magma service is of course nothing with Bazel you want to do in production, where you want to execute it, for example, in a systemd service context, but you can execute it for development reasons. Mobility D fails here with an error. The error is that the Redis database is not reachable. I don't have it set up on my virtual machine, but this is the same behavior as if you execute the service without the running Redis database. So I said Bazel also has a very extensive query language or query feature. So we might be interested for another service for current snoopd, what dependencies or has this service? What do we actually need to run this service or to build this service? If I execute this, we will see, hopefully in a couple of seconds, that we get a massive list. So this list is very large. Actually, it's more than 4,000 entries, even for the small service. But what you see here are a lot of dependencies that are prefixed with an @ symbol. These are external dependencies. They are fetched, they are put in the correct position, so it can be executed hermetically. But we might not be interested in these. So what we can do is we can add a filter and filter these dependencies. Then we get a much smaller list that might be more interesting for this presentation. So it's much smaller. And what we see here still some external dependencies, but we see here the current snoopd files, the source files. We see some proto dependencies and some dependencies from the well-known common and configuration modules. But a list might not be enough. Of course, very interesting is how the dependency structure actually looks like. And for this, Bazel offers an output graph feature. So if I execute this, I get a reformatted output. Here it is. I will quickly copy this. And this is actually dot syntax. So we can visualize it with Graphis. Here is an online viewer. Let me put it inside. And then we can see here the rendered graph for the dependency structure of current snoopd. Just a quick look. this here is the binary itself. There are some eBPF dependencies. There's a dependency on the kernel.dlib that includes all the source files of the service. We see a direct dependency to Sentry, in common. And this main arrow here that jumps over is the dependency to common service. So a dependency that actually each Python service has. And this is a bigger structure and contains a lot of proto dependencies and some other parts. So much for show and tell. Then the question, is Bazel helping Magma? My opinion about this. I've split this up in a developer and an end user perspective. So let's start with the developer. So basically the developer experience. Bazel, in my opinion, has the potential to accelerate onboarding. So a lot of questions I asked myself at the beginning, what binaries in service are there actually? So, and for this, we can use the query language again. So I ask here, Bazel query, give me all targets of the kind regular expression dot star underscore binary. So it will list me all targets that are binaries. Let's wait a little bit. Yeah. Currently wondering why it's taking so long. It's a rather small list. Yeah. Always happens if you do a presentation. Okay, let's have another look in a couple of seconds. So what binaries and services are there? Another question could be what C and C++ tests are there. You can list them all with Bazel. What tests are there for a certain service? So I can ask, give me please all Python test targets for this service. And I could ask my question, the question, for example, I will start at Magma. I want to tackle a bug task. And there's a problem in mobility D regarding event D client. And I can ask myself the question, why is mobility D even using the event D client? Well, so, and this is something I could execute here as well. So we're coming back to very quickly to the query to list all current binaries. So there are a couple of technical binaries, for example, Gazelle, but we will ignore it for now. But what you can see here are all Bazelified services. So there are a lot of Python services, enodebd, redirectd, and so on. There are the C services for AGW, the session manager, or also known as session D, SCTPD, and of course, MME with the AGW OF feature. And again, the question, why is mobility D using the event D client? And it tells me mobility D has a dependency on common service on the mconfig managers, and the mconfig managers are using event D client. So it's something that is needed for the generalized Magma service Python structure. So other points that can be solved for developers. You get a clean setup by design. So again, Bazel does not allow cyclic dependencies. And actually this uncovered something I would call it technical debt, that the MME service, it's a very large service, and this service has a lot of cyclic dependencies. So we are currently not able to split it up in smaller artifacts. It's one very, very big Bazel file, and my strong recommendation is that this should be tackled in the future, because by this we can massively increase the build time for MME, because then we have very small library artifacts. Another thing is the hermetic builds. So this has the absolute benefit that the builds will be less flaky. You will have less often the question, why does it not work in my environment, on my machine, and so on. The build times itself, I will come after the next slide to this. But first, let's take a look, why is Bazel a benefit for the end user? You have hermetic-ish artifacts. This means you have less dependencies to be installed. This means the setup process becomes less complex. This also results in less flaky installation. So Slack support questions, why is not working in my machine, hopefully will get down. Well, it's my strong assumption. You have better control of dependencies, so upgrades and vulnerabilities can be better fixed and created inside of the artifacts that will be deployed by the end user. And of course, you get more variety of distributions and architectures. Of course, this needs to be set up. But for example, currently we are focused on creating the Magma Debian file, and there are hopefully then only small changes are needed to, for example, create for Red Hat RPM packages. So let's take a little look at build times. So building MME locally with Make takes 1 minute 20 seconds. Please keep in mind that these are samples. These are not averages. This were collected by Lars, and he only executed it once. It just should give an impression. So 1 minute 20 seconds with Make. With the Bazel, it's actually 8 minutes 40 seconds. So a lot longer. But the point here is that Bazel is doing this due to the initial setup. So if you very fresh set up Magma in one very fresh virtual machine, then you have 8 minutes 40 seconds. But after that, the MME build and all its intermediate artifacts are cached. This means if you rebuild locally, you have less than 1 second. And if you rebuild locally with some source changes, you have 7 seconds. With Make, it's actually not that much slower, because as I said, there are some approaches to actually also do caching in Make. The real strength is shown in CI. So in CI, again locally. So executing all MME unit tests locally takes 21 minutes with Make. With Bazel, after the initial build, it's actually 5 minutes. And if you use remote caches, it even goes down to 25 seconds. On CI, if we execute all unit tests, this is actually done in several jobs. So I try to sum this number. For Make, it's something about 45 minutes. With Bazel, again, with remote caches, it goes down to 12 minutes. And my impression is we can even optimize that. So this means we have faster feedback for pull requests for developers, which means faster development possibilities and thus more progress. But again, these are sample runs. So, but not all is good. So I want to be honest about this. What are the current shortcomings? The first point is well known in the Bazel community for people who set up Bazel in project. The setup is not easy. It's hard, actually. So there's a lot of banging the head on the table. But on the other side, if something is set up and it's working, the usage becomes very easy. Because then if you change a file, you don't even need to do any Bazel change. If you remove a file or add a source file, you need to do some changes, but this is kind of trivial. Another point is that some features are in active development. Bazel has a couple of years, but some features are still not finished. But it's open source software. A lot of people are working on this, but currently we have to use a couple of workarounds. But my expectation is especially for Python, there are some shortcomings. There's currently a lot of movement, and we see a lot of improvement for newer versions of the rule dependencies. So what is the current state and what we are currently working on? The LTE services are migrated. The unit tests already are running on the CI. The pseudo tests, which are mostly the pipeline D tests, can run locally. Running them in CI is planned. We are currently doing a lot of cleanup of the current migrated services and extensive testing, especially integration testing. The Baselified services is shortly before creating a pull request. So this is ongoing. And actually executing or Baselifying the integration kit itself, this just started. Also, I said currently we are creating the definitions for building Magma as a Debian package with Basel. And again, the assumption is that this can be extended without much effort to Red Hat RPM packaging, for example, or whatever is needed. The container builds with Basel have not yet started, but there are actually rules to create Docker containers with Basel as well. And we have a lot of detail improvements. For example, the coverage statistics is something we want to improve cache optimizations, and more small stuff. So in a summary, my opinion, Basel has the potential to improve developer experience. We get a clean structure, we get fast cached builds. It improves the end user experience. We have less flaky setups because of the hermetic builds. And if you have more questions or need support in your pull request, feel free to join the Magma Basel channel. That's it. Thank you. Any questions or comments?
Yeah, no, thanks for this, and great work there. So one question / comment I had is that we should probably bring this up in the next TSC meeting, is that I would like to see if we can do a hard pivot to a Docker form factor, at least for the edge, versus continuing to support Debian or apt, basically. Because at least given the ecosystem members I've spoken to, like everyone is either already on that journey or is embarking on that journey. And so we should have some of our CI and infrastructure and build sort of leveraging Docker containers at the edge versus app. But it's probably a bigger conversation for the TSC, and just wanted you to be aware of it at least.
I think this is a good point, because at some point we had to decide what we want to tackle first. Do we want to create the Debian packages with Basel, or do we want to create the Docker container with Basel? But it was really hard to get detailed information what is actually currently used by people who deploy Magma in the field. We got different answers. So for now, we concentrated on the Debian file. But if we get more information, of course, then we can take a look at the Docker container builds first.
Yeah, definitely. And if you can attend the next TSC meeting, that would also be awesome. We should probably discuss that there. I'll put it up on the agenda if possible.
Sure.
Yeah, thanks again.
Any more questions for me?
Then thank
Okay.
you for staying at this long talk.
Thanks. Okay, so we have some time left. If anyone would like to bring up any agenda item, yeah, please go ahead. Okay, then. Thank you, everyone. Have a great day. Bye.
Thank you.
Bye bye.